Hey guys, shh. Lads, the following is a bus stop represented on the Argand diagram. Okay? If we take several positions of the bus stop, so for example guys, if we take some positions on the bus stop, okay, point A is 0, 0, or represented by 0 plus 0i. Point B is represented by, anybody? 0, 2, which is the same thing as 0 plus 2i. The next thing after that will be C, which is represented by minus 1, 3, which is minus 1 plus 3i. D, which is going to be 0, 4, which is 0 plus 4i. And finally E, which is 1, 3. Which is 1 plus 3i. Okay? So, what we have here is a bus stop, okay, drawn on an Argand diagram. Real axis and imaginary axis. Now, explain what happens under the following transformations, okay? So, the following transformation, right? Transformation 1 is going to be Z1 equals plus 5i. Oh, sorry, less than that, plus 2i, excuse me. What does plus 2i do? 2i adds on 2i onto every one of these. So what happens when you add on 2 onto every one of these? It goes up. So for example, it's now going to be this point here, this point here, and this point here. Do you see that each point raises up? 2. And basically your full diagram, your bus stop, gets shifted up by 2. Is everybody happy with that? That when you add on 2i, it ups the bus stop by 2. This is what's called a translation, okay? Now, the other thing we can do is something like this, where we have Z1 was plus 2i, and we said that moves it 2 up. What would happen if I said Z2 was minus 3i? What would happen there? It'd move everything 3 down. Do you understand? So it would go from here, the top of this part here would end up here, this part here would end up here, and this part D would go 3 down to here. And basically the circle of your bus stop would be located here, and the stem would be directly underneath, 2 down. Is everybody happy with that? Alright, the next one, the next type of change that can happen is this. What happens if I said Z3 was worth plus 3? Just 3.
3 to the right.
3 to the right. So look, 1, 2, 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. And 1, 2, 3. And you can see the outline of our bus stop here, which would be here and now here. Is everybody happy with that? That's 3 to the right. Now guys, this is how complex numbers are in using animation and computer graphics, that they basically translate everything over. Okay? So another example would be what happens if we did this? Z4 is going to be, looking guys, Z4 is going to be, let me think, Z4 is going to be 2 plus 1i. What does that mean? 2 across, 1 up. So look at this. 2 across, 1 up. 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 And as you can see, our full bus stop has taken a diagonal movement upwards. Okay? Now, the really difficult ones come in the part of rotations, okay? So we said Z5 was multiply by I. Multiply your original one by I. What happens when you multiply by I? Let's find out what happens. What happens when we multiply A by I? What's 0 multiplied by I? 0. So look, I'll put all of these in brackets and then I'll multiply them by I. And I'll show you what happens. Okay? When we multiply it by I, look what happens. I, and I. Okay, this one still turns out to be 0. This one turns out to be 2i squared, which is the same thing as
Minus 2.
Okay? Just minus 2, right? No i's in it. Okay, what about this one here? Minus I minus 3i squared, which is the same thing as?
Plus 3 squared.
Plus 3. No I. 3 minus I. Okay, what about D?
No. That's it.
How does that minus I?
Plus 3 squared turns into.
Oh, sorry. Plus 3i squared, you're right, sorry. Minus 3 minus I.
Alright.
How is that I anyway?
Because I multiplied I by minus 1 to get minus I, and 3i by I to get 3i squared, alright, which turns into minus 3 subsequently. What about D? It's going to be 4i squared, which is minus 4, and E is going to be I plus 3i squared, which is going to be
3 minus 3.
minus 3. Oh, sorry, it's an I, sorry. Plus I. Now, guys, look what happens when we draw all these points out. Okay, ready for it? 0. A stays at position A. So this is A, B, C, D, and E. Their image, okay? Now look what happens with B and look what happens to B. B goes from 2i and it turns to minus 2. B is over here. C goes from 1 minus 3i, which is originally here, and it turns into minus 3 minus I down here. D turns into minus 4, and then E turns into minus 3 plus I. And what can you see happen to it? Undergoes a 90-degree rotation. So it went from up here to down here. Okay? And that's how it's used in computer graphics. Okay? Now we're going to try another one. And the one I want to try, which is this. You should be able to do it. Okay? The next one I want you to try is this one here. Okay? We're going to multiply by minus 2i. Now look what happens this time. Okay? We're going to multiply the full thing by minus 2i. So it doesn't do everything. I'll just sit there a second. Okay, so that's just getting rid of that there. Okay, there we go. Now, the last transformation is going to be Z6, and Z6 is going to be multiplying by minus 2i. Now, what happens when you multiply by 2? Makes the full thing bigger, twice as big. Okay, and if you sorry guys, what I'll start off with is I'll start off by multiplying by 2 on its own. Multiply by 2 on its own. Okay? So it could be represented by 2 times the original value. Okay? So if I multiply by 2, look what happens. D goes from 4 to 8. E goes from... E was 1 across. Now it's going to be 2 across. Do you understand? Both its width and its height get multiplied by 2. So it's going to be 1 across and twice the amount up, which is going to take me to 2. 6. C is going to be 1 more. It doubles its size across and doubles its height upwards. And look what happens now. And then B is 2 up, which is here. All of a sudden, all of a sudden, by just multiplying by 2, we get a bus stop that's twice as big in stature by multiplying the complex number by 2. When you multiply a complex number by 2, you double its size. Do you understand? Okay, now finally what we're going to do next is we're going to multiply by minus 2i. Now look what happens this time around. Minus 2i times the original. The original means the original diagram. Now look at this. Okay? Now, the original diagram, we're going to multiply all these numbers by minus 2i. So I'm just going to put minus 2i behind each and every one of them. And then once again, we're just going to make a little table here, okay, of the answer, the workings, and then the point. Okay, so look at this, guys. Multiply by 2i, what do we get? 2i times 0? 0. Because it's on the origin, it never changes its value. So it was originally 0, so the point we're going to draw is 0, 0. What about this one here? Multiply by 2i, what do we get? Minus 4i squared, okay? Okay, and what's minus 4i squared? Plus 4, which is the point 4, 0. What about the next one? Multiply that by 2i. We get minus 2i minus 6i squared. What's that? 6 minus 2i, which is the point 6 minus 2. What about the next one?
0. Up here's the other way, right?
The minus 2i, i's always go at the end. I-axis is the I value is the j value, which is the second value.
We can see in the B1 there when it's minus 2 into the bracket of 0 plus 2i. Put it 4, 0.
Sorry. There where the problem was coming in was something like this. If I had 4 plus 5i, what this means is 4 cross 5 up into the air, which would be located there. If I had 4 minus 5i, it'd be 4 cross and 5 down. So in effect, 4 plus 5i is the point 45. 4 minus 5i is 4 minus 5 on a standard xy plane. Okay? So if you just keep an eye on the values here, okay? So for example, 2i multiplied by this is going to be minus 2i minus 6i squared. Oh sorry. I'm on the wrong one. I'm on D. Sorry, I'm on D, excuse me. I'm on D. D is 2i times 4, which is minus 8i squared. And what's minus 8i squared? Plus 8. Because it's minus 8 times minus 1, which is 8. Just going to be the point 80. Finally, 1 plus 3i multiplied by 2i minus 2i minus 6i squared, which is going to be sorry guys, 2i multiplied by minus 1 was plus 2i. Sorry, that's where I made the mistake initially. And now this one is 6 minus 2i. Now guys, look what happens here when I plot all these points again. 8, 0, 4, 0 is here, 8, 0 is there, 6 minus 2 is down here, 6, 2 is up here. What have I done by multiplying by minus 2i?
Rotated it.
I wrote the minus I rotated it clockwise, and the 2 doubled their size. Okay, good. The following is we have three equations here, okay? And what you might be asked to do sometimes is to predict the shape of the graph, okay? So for example, the first one, okay, was y equals, you gotta keep an eye on the power of x. So it's x cubed, what's the next part? Minus 2x squared plus 6x. Minus 2x squared plus 6x. So, x cubed, Luke, put it away. Okay, x cubed minus 2x squared plus 6x minus 3. Okay, so look at this, plus 6x minus 3. If you were to put that in your calculator, okay, what happens is, sorry, just have to find where it went. Okay guys, when you have a cubic function, when the cubic function has x equals 3 on it, for example, okay? So anytime it has an x equals 3, what can happen is it usually has two turning points. X to the power 3 has 2 turning points, okay? Quadratic equations, like this one here, y equals x squared minus 5x minus 6, they usually only have 1 turning point. If it's a minus x squared, it's going to be an n-shaped graph. Plus x squared, u-shaped. Minus x squared, n-shaped. If it doesn't have an x squared in it, straight line. Is that alright? Okay. Now, the next type of question is this, guys, okay? Another type of question here. This is the third question we're doing today, okay? Question is this, okay? We want to enclose a farm, okay? And what we want to do with the farm is this. We want to enclose basically the outside of a farm, okay? Now, what happens is, one side, this side here, is a concrete wall, okay? The concrete wall costs let me see, 600 euro. Okay? And then after that we want fencing. Okay? And each piece of fencing costs an extra 20 euro. Okay? So what they want you to write down is part 1, and you have the wall is compulsory, okay? So what you're going to say is find the costs of the wall and 3 pieces of fence. How'd you do that? So how'd you get the wall plus 3 pieces of fence?
All the fences X.
Sorry?
Potentially 20 yards.
So we're 20 euro each, so it's going to be 600 plus 3 times 20, which is equal to 660, okay? The next part here is going to be basically what happens is there's a sequence involved here, okay? If you were to look at a table of this and do a table with the number of fencing, okay? So for example, 0 fences cost 600 because the wall's compulsory. 1 fence is 620, 2 fences 640, 3 fences 660. What type of series is this? This is an arithmetic series. The arithmetic series gets you basically, it's going up in 20s, okay? Now, what I can ask you is, find the general formula for the cost. It can say, find the general formula for the costs of enclosing the farm. Now, there's a formula for that, okay? And does anybody know the formula? Sorry? Tn. Okay? So Tn is going to be A plus N minus 1 times D. Can anybody tell me what A is? A is what, guys? The initial value. A is the initial value. And what's D? The difference in value each time, which is 20 euro. When you multiply this out, you're going to get 600 plus 20n minus 20. Is that right? And then you're going to get 600. So you're going to get 580. Sorry, A is the initial value. Oh, sorry guys. See the 0? Now this is something to know here, right? The first term is not 600 because you have to have 600. You have to have 600 with a piece of fence attached, okay? So technically speaking, I would have got these numbers slightly wrong. So what would be is this would be 1, 2, 3, 4 and 5 if the A value is 600. Okay? So what we have is 600 plus 20n minus 20. That's going to be 580 plus 20n. Now look what happens. When n equals 1, what's the answer? When n is 1, 600. When n equals 2, 620. So by using this formula, what they can then ask you is, they can then go find the costs. They can then say find the cost of the wall and let me see, the wall and let's say 50 pieces of fence. And how would you find that?
15 there.
Sorry?
15 then.
50 for n, so it's going to be 580 plus 20 times 50, and what does that get us? 1,580. Another thing they can ask you is this, guys. After, you can say, let's say John has a budget. John has a budget of 1,260. How many pieces of fence can he afford? Sorry? So how many pieces of fence can he afford? Okay? So what it is you can do it 2 ways. You can use your formula, your 580 plus 20n. 580 plus 20n equals 1,580. So what you do is you bring over 1,260. You can bring over the €580 over the other side. And what is 1,260 minus 580? I think it might be 680. And then divide 680 by 20, and how many pieces of fence can you afford?
34.
34 pieces.
I have to do that.
Right, lads, the reason why the first term of the series N1 didn't include any pieces of fence. Therefore, N2 is one piece of fence. This means that N34 is 33 pieces of fence. Okay? Now, there's another way of doing it that most people probably would have done, was you just would have taken away your €600 and divided by 20. Right, there's more than one way of doing it. It's this, okay? What we have here is a person who's on the edge of basically on the edge of a cliff, okay? Now what he does is, okay, the cliff face is, let's say 19 meters tall. The point at which he throws the object is 1 meter tall. Okay? He then throws the ball from how far above the ground would you say? Including his 1 meter of height to his arm. 20. The ball starts off 20 meters above the ground, okay? Now what happens is he throws the ball up into the air and it undergoes basically a throw up and down, okay? Now, this formula here is described above the ground in the following manner. Okay, so there's a formula given for the placement above the ground, okay? And the formula is S or D, which is usually the distance, okay? Or it could be H. H is the height. It's going to equal 20 minus T squared minus, let's say, we need something reasonably small, minus 2T here. Okay? So this is grand. Now, what I might ask you is, after how long does it hit the ground? When does it reach its maximum height? Stuff like this, okay? These are questions I can ask. So, an example would be for let's say part A, okay? What is the initial height? We know that it's 20, don't we? So guys, what is the initial height? We know that initial height is 20, well how would you prove it? You prove it by saying, when the question starts, T equals 0. If you replace T equals 0 into this formula, what will you get for H? 20 minus 0 squared minus 2 times 0 equals 20. Okay, they can ask you that. Okay? Another question they could ask you is this. Okay? At what time, are you listening guys? At what time does it reach its greatest height? Now, greatest height, guys, is basically when the speed is 0. Now, what you need to learn about differentiation is the first derivative. If you're given an equation that is represented as distance or height, the first derivative is speed. So differentiate. Now if you don't remember how to differentiate, here's how you differentiate, okay? 3x squared, for instance, you bring the 2 to the front and take 1 away from the power. So when I differentiate this, what do I get? 2 times 3? 6x. If I differentiated, let me see, 12x3.
Apologies for interrupting classes.
Hey, continuing on. To differentiate 12x cubed, you bring the 3 to the front, multiply it by 12, and then take 1 away from the power. So for example, if I want to differentiate minus 1 times t squared, you bring the 2 to the front, multiply by minus 1, and you get minus 2. Okay, minus 2t. And what happens when you differentiate? When you differentiate a number that hasn't got a power, so when you differentiate 3x, you get 3. When you differentiate minus 5x, you get minus 5. So what we're going to get here is minus 2. Now, when the speed equals 0, when this equals 0, okay, you put the time equal to 0, and sorry guys, this should be 2t plus 2t by the way, the formula, and you're going to get 2t equals 2, t equals 1. It reaches its greatest height after 1 second.
What's next up?